Hello everyone. Now today we're going to calculate pH and we're going to use three different examples to demonstrate how to use the various formulas in calculating pH. Now before I start, I want to just quickly remind you about something, and it is about how to use your calculator when calculating pH. So first, I want you to identify your log button on your calculator. So once you identify your log button, you're pretty much good to go. But I also wanted to note your inverse log, which is just above your log. And to get that, you'll press your second function and then you press log. Or you may press your shift button on your calculator and then you press log to use your inverse log. That's going to be a very important button to use. Additionally, I want you to notice this special button that is called the exponential button. And here in my calculator, it will be double E. For some calculator, you may see EXP or EX. So I want to identify those three buttons before we actually start. All right, once you have done that, now let's get into it. Now let's look at the various formulas and make sure that we understand the various formulas. Now the first one I want to bring your attention to is the one on your left. And I want to notice that the H plus in bracket is representing the concentration of hydrogen ion. So pH is equal to minus log multiplied by the concentration of hydrogen ion. The one on the right is pH equals to minus log multiplied by the concentration of hydronium or oxonium ion. So H3O plus is representing the concentration of hydronium or oxonium ion. What's the difference? There's no difference really, because they can be used interchangeably. So whichever one you see, they mean the same thing. However, the H3O plus is actually representing the hydrogen ions in a solution, aqueous solution, in fact, because the H plus ion will react with water, and that is why you have H3O plus. Now, the other formula I want you to notice here is the pOH, which is the percentage hydroxide ion, and that is calculated similarly as the pH. So therefore, the pOH is equal to minus log multiplied by the concentration of hydroxide ion. A very useful formula also is pH plus the pOH is equal to 14. And remember, 14 is the maximum number on your pH scale. All right, so once you add those two values, you should get 14. All right, now let's go into our first example. And we're looking at a solution of phosphoric acid, and it has a concentration of 2 times 10 to the minus 3 molarity. And I want you to notice, once you get a question, you always want to work out the molarity, all right, which is moles per dm cube or moles per liters. And that's very important to do your conversion, do all the conversions first before you start do any calculation. Now what we're going to do, we're going to calculate all these different variables. So we're going to look at the concentration of H plus ions. We're going to look at the concentration of OH, OH minus ions as well. We're going to find the pH, and we're also going to find the pOH. All right, so we're going to find them based on using the different formulas. So let's go through it now. And the first thing we're going to do is point out that in the phosphoric acid, we have 3 positive ions. So in other words, in a solution, the H3PO4 will dissipate 3 H plus ions. All right, and that's very important for us to understand that. All right, so Importantly, since the concentration of H3PO4 is 2 times 10 to the minus 3, then the concentration of H plus ions will be 3 times that amount. And that is why we indicate here that H3PO4 will dissipate 3 H plus ions. All right, so therefore it will be 3 multiplied by this. So it's 3 times the amount, the concentration. And so therefore the concentration of H plus ions will be 6 times 10 to the minus 3 molarity. And so we could put this down for our answer there. All right, so once we find the concentration, then we can go ahead now and find our pH. And so pH, again, remember it is the minus log multiplied by the H plus ions. And so let's just quickly substitute and put our values in. And so therefore pH equals the minus log multiplied by 6 times 10 to the minus 3, which is the concentration of H plus ions. Now I want to point out right here, once you press your minus log, all right, on the calculator, remember that minus, that log button, right? So press minus, then you press the log, and I want you to use your EXP button at this time, or your exponential button, whether it is double E or EXP or EX on the calculator. Once you press that button, press 6 first, and then press the exponential button without pressing times 10. Do not do that. Just press 6, EXP, then you press minus 3. Okay? So it is 6 exponential minus 3. Okay? And then you will get your answer once you have done that. And you should have, see on the calculator at this time, 2.22. And so therefore our pH is 2.22. And as you know, anything below 7 must be acidic. So this substance, which is H3PO4, is acidic. All right, so let's put our answer there. All right, now let's do another calculation. But once we have our pH, it is easier to find our pOH rather than finding our concentration of OH minus. All right, so let's quickly put our formula up here, which is pH plus pOH equals to 14. All right, and so once you have that equation, we can make pOH the subject of the formula, and therefore pOH is equal to 14 minus the pH. All right, so let's quickly put our pH, which is 2.22, in this equation. So therefore, pOH is equal to 14 minus 2.22. And here we get 11.78. All right, so the percentage of OH ions in this aqueous solution will be 11.78. Now, we can now find our concentration of OH minus. So again, I want to remember the formula that we're going to use here. And similarly to find pH, we find pOH in the same way by saying that pOH is equal to minus log multiplied by the concentration of OH minus ions. Now, the thing is this, I want to point out something to you really quick. Here, to substitute our values, pOH is 11.78, so I want you to notice that. And then it's going to be minus log multiplied by the concentration of OH. Now, the thing is this, I want to point out to you that if you think about it, all right, really think about it, to make the OH minus, or the concentration of OH minus, if you use this equation, you should get 11.78 over minus log. But you cannot put that in a calculator. You will get a syntax error or mathematical error on a calculator. So I'm going to demonstrate how you actually do this. And this is part that I really want you to understand. Now, to plug this in a calculator, really, if you think about it now, the minus log is really an inverse of the 11.78. So the way the calculator will read this, right, you have to put in your inverse log first. So you're going to press your shift button and your log, all right, and you're going to get, actually the inverse is actually 10 to whatever value. However, we have to account for the minus, so therefore we're going to say inverse log minus 11.78, and that is how you work out this equation without saying 11.78 divided by minus log, because the calculator again will not recognize it in that sense. So you just press your inverse log, then you press your minus 11.78, and that's the only way the calculator will recognize it. All right, so the answer should be here equals to 1.66 times 10 to the minus 12 molarity, and that is the concentration of your OH ions. All right. I don't know if you have a super calculator that will read it differently, but as far as I know, and all the calculators that I've tried, you have to go to the second function and then press log, then press the minus the value of the pOH value. Okay. All right. So just to make sure you practice on the calculator to make sure that you understand how to use it, and that's very important. All right, let's jump to another example because we're looking at 3 different examples. All right, so our next example here, this time we're using a solution of calcium hydroxide, and it has a concentration of 5.56 times 10 to the minus 6 molarity. Now this time this is a alkaline solution. All right, so I just want to notice that OH is alkaline solution. All right, so let's now quickly jump into it, and we're going to go a little bit faster with this one since we understand the concept, because this will be similar. The third example will be a little bit different from these two. All right, so first, I recognize the number of OH ions that can be dissipated from this solution, and it is 2 of them, okay? All right, next we're going to use our formula to find our concentration of OH minus ions, and since the solution has 5.56 times 10 to the minus 6 molarity, then the molarity of OH will be twice that amount, okay? And so therefore, the concentration of OH minus ions here will be 1.112 times 10 to the minus 5 molarity, and so we could put that answer in. All right, and notice sometimes you have to find a certain variables first before we go to another variable. All right, so once we find the concentration of OH ions, now we can jump into finding our pOH. And pOH, again, remember it is minus log multiplied by the concentration of OH minus ions. All right, so here to plug this in the calculator, you're going to press minus log again. Then you press 1.312, your exponential button, minus 9. All right, and then you will get your answer, which is 4.954, and that is our pOH value. All right, so now notice we're working backwards compared to the first example, because here we have an alkaline solution, so we must find the concentration of OH ions first, and also the pOH, then we can find our pH. Now once we have our pOH, now we can go ahead and find our pH. And so therefore our pH plus pOH is equal to 14. And so therefore by substitution, we should get pH equal to 14 minus pOH value. And our pOH value was 4.954. And so therefore, we should get 14 minus 4.954. And so therefore our pH value here is 9.046, and anything above 7 must be basic or alkalinic. And so therefore this solution here is a basic solution. All right, now we can now put that in as our answer, which is 9.046. All right, now let us quickly find our concentration of H plus ions, and now is the reverse of finding the pH. All right, so let's just use a formula. So our pH, remember, is equal to minus log multiplied by the concentration of H plus ions. Now, again, remember how to put this in a calculator to find the values. Again, because our pH value is 9.046, which is equal to the minus log multiplied by the concentration of H plus ions. To put this in the calculator, remember, you have to use the inverse log, all right? Then you press the minus value of the pH, okay? So therefore, we have our 10 to the minus 9.046, and this is just the inverse log, the minus value of the pH. And so therefore, you should see on the calculator 8.995 times 10 to the minus 10 molarity, and that's our answer. Let's quickly put that in. All right, so by now you must be a pro in using a calculator and finding the inverse log value of the pH and also finding your pH and pOH. Let's jump to our third and final example. And for this example here, we're going to determine the pH of a mixture. So now we have a mixture now, and this mixture that we have here, we are actually using 4.2 times 10 to the minus 4 moles of sulfur trioxide, and we're dissolving that in 2.8 liters of water. All right, so now this is mixing two different things. All right, so what I want you to notice, that is pretty much a dilution of the sulfur trioxide. However, let's look at the equation that this will be, because what is happening here, the sulfur trioxide will actually react with water, and once it reacts, it will produce an acid. So the equation here will be sulfur trioxide plus water to give you sulfuric acid, okay, which is H2SO4. All right, so again, if you even think about this in this way, this is like forming like acid, similar to forming acid rain. All right, when oxides of non-metals react with water, they form acid. So this sulfur trioxide is an acidic oxide, okay? An acidic oxide reacts with water to form acids, all right? And again, it's similar to forming acid rain, all right? Just to point that out real quick. All right, so from we have our equation now, we can consider how to calculate now our pH. All right, so the pH of the solution, we're going to use the H2SO4 because that is the final product. That is the mixture or the result of the mixture. All right, so the first thing here, we can find our concentration of H2SO4. And so we're going to divide the mole by the volume. And so dividing the mole by the volume, you get your molarity. And so therefore here we should get 1.5 times 10 to the minus 4 molarity as a concentration of H2SO4. Once we have this now, we can go ahead and calculate our concentration of H plus ions. But before you do that, you have to identify the number of H plus ions that will be dissipated from this solution. And since this is H2SO4, then we should get 2 H plus ions. All right, so therefore the concentration of H plus ion will be 1.5 times 10 to the minus 4 multiplied by 2, because it produces twice that concentration here based on the formula of sulfuric acid. All right, so next thing we're going to do here, once you have that concentration, which is equal to 3.0 times 10 to the minus 4 molarity, then we can go ahead now and find our pH. And so pH, again, remember, it is equal to the minus log multiplied by the concentration of H plus ions, which is 3 times 10 to the minus 4. All right, so substitute with this formula. And once you substitute in this formula, we should get the pH is equal to the minus log multiplied by 3.0 times 10 to the minus 4. And so therefore, again, you should get this on the calculator, 3.52. All right, and so this mixture will produce an acid. So the pH is low, which is below 7, which means it is acidic. All right, so this is the end of it. All right, and I just want to tell you that I truly appreciate you watching this lesson and other lessons as well. And I just want to leave you with a quote. I just want you to know that hate is like acid. It damages the vessel in which it is stored, and it destroys the vessel on which it is poured. So please do not keep any hatred inside of you, and do not dish it out on anyone as well. So I want to keep safe, be blessed, love yourself, love others. Peace.